Okay, today I'm going to give a breakdown of the save load system that I've built for Cultist Astronaut. In no means is this a complete polished system, it's just the very basics to get something up and running. In this example today, we're going to look at saving and loading health, which I've already built, and then we'll add a position so we can spawn the player in a specific position in the level. First thing first, what we've done to the scene is we've added three important components. The first two are the save manager and the save debug script. Save debug script is very simple. All it does is call save and load for the save manager. And then we'll get a message, of course, so we can visually see that it's saved and loaded the data. The save manager is actually a singleton, but it's a very focused singleton. And what it does is it tracks all the save file identifiers in the scene. And the reason why we made it a singleton is so save file identifiers can register themselves on start when the scene loads. But that's why we have this as a singleton. It makes it really easy to register and unregister if this object is created or destroyed. So those are the two different things. This allows us to register our serializable components, and this allows us to save and load. The third thing we added was to the player, and it is called the health serializer. So the way this works is you can build serializers for specific components for specific data that you want to save. And this health serializer is a save file identifier, which means that it has a unique GUID, which is exposed in the inspector. Again, you don't want to save this to the prefab. You can see it has a plus icon on it. If I save this to the prefab, it means that every player instance will have the same GUID, which actually in that case it's fine, but you can imagine this can be pretty bad if we save it to the peeler or the cutter cop. That's one prefab where there's a dozen enemies that are the same. But yeah, that's the health serializer, and what it does is it captures the health data from the health component. So I can add more or less data to this, but in this example, I'm only interested in saving and loading the current health. So this get function will create the health data and return it. And you can see it returns an interface of iSerializable data, which is actually an override from the save file identifier. And this is important. This is how we save our data. So we'll get to that in a second. There's the health data component. Like I said, we can add more. This is the actual class that gets serialized by Newtonsoft. And then the health serializer is basically a way to save it and then, of course, load it. So the set function will convert that data to health data and then pass it into the health component and then tell the health bar to update. If you don't add this, the health bar actually stays full until you get damaged. So we have to tell it to update the health bar as well. And of course, we grab the health component on the game object, which is, if we go back to Unity, you'll see that the health component is on the same object. Now, how does this all work? Well, in the save manager, what we do is when we call save, we actually loop through the serializable components and we create a save entry. Now, save entry is just something we can serialize with Newtonsoft. And if we go to this class, you'll see it's made up of two things, the ID that we're saving and the data associated to that ID. So in this case, we grab the save ID and the data from the serializable component, which is the health serializer. And you can see it also grabs the data. So this is calling the function for this. And then what we do is we serialize it to JSON using a custom JSON serializer, which handles type name handling. Essentially, this JSON will know exactly what type of data it is, and in the file it will say health data as the type. And of course we indent the JSON so it looks nice to read. And we do something very similar for load. The load will actually open that same destination. It will set the same parameters so we can deserialize it, and it will convert it back into a consumable save entry list that we can then pass to each serializable component. And this is where the ID comes in. We use the ID to grab the exact component. You can see it spits out a save file identifier, and then we set the identifier's data to the data we loaded from the file. Now, one thing to keep in mind is we could have data from 5 different scenes, but since this object only tracks what is currently loaded, as we saw with this, it actually registers it on start. And again, we can add a destroy. This is what's missing. We could do an unregister, which we don't currently have. And so let's say we load and unload a scene, it will no longer be in the save manager. And so this save manager is only concerned with updating things that exist in the scene, which is why we do a try get value. So if it doesn't find it here, it will skip it, which is completely fine in this case. However, when we do get to the second scene, we can then call load again, and it will make sure that all the serializable components in that scene are updated to match the file. So we can pack everything into a single file, and then it will pick and choose based on what is registered to this dictionary. Okay, that was a lot, but basically, yeah, you have your save manager. You create a custom serializer that is a save file identifier, which handles converting the component data over to iSerializable data. And then, of course, we have the debug script, which lets us click U or I to save or load that data. So let's give it a shot. Okay, we are now in the game. You can see I have full health. What we're going to do is take some damage. So I took 3 damage, so I should have 7 health. I'm going to click save. You'll see down here in the message it says saved. I'm going to turn the game off, and I'm going to click play again. And now that we're back into the game, you'll see I have full health again. If I click I, you'll see it will load that data from the file and then update the health bar. Yeah, and I can take more damage, and then I can load it again, and you'll see I'll be back up to 7 health. Now that's the only thing we're saving, so not much is updating. Like, we're not updating the position, we're not saving like a current checkpoint. We can take this even further. We can save the current room the player's in, the current scene the player's in. Really, we can do whatever we want with this system. So let's add the position next as an example of how expandable this is. However, before I do that, I want to show what this file looks like. So here's the Infinitive Game Studios Cultist Astronaut folder. Inside this file we have, or this folder, we have a save.json. And if I open this up, you'll see that we are capturing a save entry list. And in that save entry list, we are capturing data for health, and we're tracking current health as 7. One of the limitations of this system is if we rename any of these components, we can invalidate the save file. So if we ever release this game and people have save files, we'll have to keep in mind that we can't really rename scripts. And if we do, we need to have some way to update the JSON so that it's in the new format. Okay, let's add a custom serializer for position. Another limitation to the system is you have to create a component for each data you want to save. Technically, I could create a player serializer which handles health, position, all of that. But in this case, I'm just going to make it very generic and very decoupled, and I'm going to create a health serializer and a character position serializer. I'm going to go very granular with this. Actually, I'm not going to create it here because this takes a while. I'm going to actually create it over here. So I'll create it right next to this guy, public class character position serializer. I spelled that wrong. Serializer, right? No. Oh no, I spelled that right. And this is going to be a save file identifier, just like the health serializer. And then of course we will add the serializable data. And I think for this, what we can do is we can capture the vector by itself. We could create another class like health data, but I'm just going to capture a vector3 for this example. So in the get function, we will add vector3 position, and then let's return position. Oh, actually, we do have to create a class. My apologies, because it has to inherit the serializable data. So this will be called position data, and this will be serializable data. And then we will store the vector3 position. And it's important that we include get set because this will be serialized by Newtonsoft. And then down here, we can say position data equals new position data, position, and then of course we have to capture the position of the player. Since we don't, we could technically grab like the Corgi controller or whatever, but since this is going to be attached to the same object, we'll just use transform.position. And then we'll return that data to the get function. Let's clean this up a bit so it's a little cleaner and easier to read. And then of course for the set, we will have to cast it. That's another limitation of the system, is you have to cast the data when you read it in. So we'll do value, and of course we need this to be position data. And then we will do transform.position equals data.position. So like I mentioned before, this is essentially our save and our load. And I think that's all we need to create. So let's move this to a separate class since it's a mono behavior. And while we're at it, we'll move this to a separate class. Okay, cool. Let's take a look here. So we have the position serializer. I think this is all we need to do. So let's go into the Cultist Corgi game object, and let's add this to our character. All right, let's add this component to our character. So we want to use the position, or the character position, oh there it is, character position serializer. You'll see it has assigned it a unique GUID. And like I mentioned, we could create a player serializer, have one GUID, and we can capture both health and character position. The reason I like this is we can actually reuse these components for objects or characters. Technically, this could just be a position serializer because it's not tied to a character. So we can make these more generic so we can use them across a wide range of objects, or we can make it very specific to the player or to player stats, anything of that nature. Okay, and I think that's all we need to do. So let's give this a run and see if it captures our position. All right, cool. We are now in the game. So let's take 2 damage. And then let's put ourselves right over here at this edge of the screen. And then let's click U to save the game. Oh, and looks like we have a self-referencing loop detected for property normalized with type vector3. Oh, and that is because we are trying to serialize a vector3 class and we don't have a vector3 contract. So since vector3 is a custom data type, it's given us some trouble. So what we'll do instead is we'll update our position data class so that it captures, let's see here, how do we want to do this? We can capture, I guess for now we'll capture 3 positions. There's a better way of doing this, of course, but this is just to get the example working. Over here we'll have to do a little bit more work. And of course, we're now using multiple transform.position, so we can break that out into a variable. So we'll do that now. Let's get this up here, position. We convert that. And then over here, we can do new vector3, position.x, data.position.y, and data.position.z. All right, perfect. Let's let that recompile. Let's give it another shot. All right, cool. We are now back in. Let's see if that fixed our issue. So let's lose 2 health. And then let's go stand in the corner. Let's click save. We've saved the game. Now let's run over here. Let's click I. And you'll see it teleported us back. Now we're also not capturing like the direction the player was standing and all of that. I don't think that matters as much because you can imagine like I'm done playing for the night. I'll save my game and then I'll come back. As long as I'm in the same spot, like we should be good. Chances are they'll be aiming in the right direction anyway. And yeah, let's make sure the health is still working. So let's close this. Let's start over from complete scratch. All right, we are back in the game. Let's see if loading works. Yep, and you'll see that I now have 8 health and I'm in the correct position. And before we end the video, let's take a look at the save file and see if it's updated correctly. Yep, and you'll see now this save entry list has 2 values. It has one for the position data, and it also has one for current health. And the nice thing is we can remove data from this, and the system will still load correctly. So let's load that, and you'll see I have full health and I'm in the correct position. So yeah, that was a little bit of an overview of the system I built and how you can add custom serializers to your game objects. But yeah, hopefully this was helpful and we can expand this system to support more save and load functionality.